All right, guys. So we're going to talk about trigonometric ratios again, but we're going to be doing it on the unit circle today. All right. So go ahead and copy that picture down there. I'll give you a moment. So yesterday we were looking at pictures like this, right? And call this angle here theta. We found the radius is always 1, right? And the horizontal value tells us our x coordinate, right? And the vertical value tells you our y coordinate, right? We good? It's from yesterday. Okay. Well, what we're going to do is we're going to do some trigonometric ratios. So you guys remember sine, right? Sine is opposite over hypotenuse. So what would opposite over hypotenuse be for this triangle? Y over 1, which we can really just simplify to be y, right? Theta. That's how I write my thetas, but it's just a circle with a line through it. It means the angle. Okay, now let's do cosine. Cosine of theta. What would that be?
Opposite over, adjacent over opposite, or adjacent over hypotenuse.
One of those. Adjacent over hypotenuse. So that would be x over 1, right? Okay, now believe it or not, we've just done something mind-blowing. Okay? What we've just proven is that if you ever want to find out what x and y are, you just have to do sine of theta and cosine of theta. Do you guys see that? Sine of theta tells you what y is. Cosine of theta tells you what x is. Okay? So let me demonstrate that to you a little bit. Let's do 30 degrees on our unit circle. Okay, so let's find out what sine of 30 and cosine of 30 is. Can you guys get out your calculators and figure those out? I'll call on you to share out your answers in a moment. Let's do sine of 30 first. So go ahead and do that. So calculate sine of 30.
It's like 30 sine.
Yeah. So how about Jalen? Did you get it yet, Jalen? What did you get?
I got
0.5. Okay. Now let's do cosine of 30, please. Maya, what'd you get for that?
0.86. Yeah, gotta put 30 first.
Okay. Now, look at your guys. Get out your unit circles. Get out your unit circles. Now, what I just got through showing you guys on this slide is that sine tells you what the y value is. Cosine tells you what the x value is. So sine, this should be my y value, and this should be my x value. So look at your unit circle, find where it says 30 degrees. What is the y value? 1/2, right? And isn't that 0.5? Now the x value is radical 3 over 2, correct? But take your calculators right now on your phones and do square root of 3 and divide it by 2. Do the square root of 3 and divide it by 2. What are we getting? 0.86, the same thing. So this is the decimal form of radical 3 over 2 here. Okay, so we just realized something. Now, if you want to find out what your coordinates are, really all you need to do is push cosine of your angle and sine of your angle, and you've got your x and y. Okay, now that's good on the one hand, because now you can find any coordinate you want to on the unit circle. So on our unit circle, we only have the 30s and 45s up there, right?
Yeah.
But what if I asked you what's the coordinates for 70 degrees right here? That's not on our unit circle, so you wouldn't be able to figure out what the x and y are using any sort of special right triangles, right? So what we can do, though, is just do cosine of the angle and sine of the angle, and that will tell you what the x and y coordinates are. Okay, so that's one good thing about it. The bad thing is that I don't want you guys to think, oh, well, now I don't need to memorize the coordinates around the circle because I can just push cosine and sine and get the answers. The problem with that is I need your answers in radical form and fraction form for those, and your calculators typically give it to you in decimal form. So you do need to memorize them still. But there's our big aha, is that sine and cosine just tell you what x and y are on your unit circle. But we're going to do the other trig ratios now. Now tangent. Tangent is opposite over adjacent. So what would that be? What would tangent of theta be? Y over x. So now we know that if you ever want to find tangent of any angle on your unit circle, you just take the y coordinate and you divide it by the x coordinate. That's it. Now the other ones, the reciprocal ones. Cosecant is the reciprocal of sine, right? Cosecant is hypotenuse over opposite. So that will be what? 1 over y. Secant is the reciprocal of cosine. So what will that be? 1 over x. And cotangent is the reciprocal of tangent, so that will be x over y. So now today I'm going to ask you guys what's cosine. And it's correct, but I don't want you guys to say adjacent over hypotenuse. When I say what's cosine, I want you to say it's x. Or if I say what's tangent, I don't want you guys to say opposite over adjacent. I want you to say y over x. Okay? So when I ask for those today, you're going to have to look back here to remember what they are when I ask you for that. I see some pins. Let me show you what we're going to be doing today with this then. I'm going to put student practice over here. Both of them have the same instructions. It's going to be find the trig ratio for each angle. Find the trig ratio for each angle. Okay, so here we go. Let's start off with sine of 120. Sine of 120. Okay, so the first thing you're going to have to do is know what that trig ratio is. So what's sine? It's y, right? Now some of you guys might think, oh, I thought it was opposite over hypotenuse. We're not doing that today. Today we're using that little list I gave you. That is opposite over hypotenuse. But all of our answers are going to be x and y. So when I say what's sine, what are we going to say?
Y.
It's the y value. So what we're looking for is we are looking for the y value when the angle is 120 degrees. What is that y value at 120 degrees on your unit circle? It's the square. Do you guys see that?
2.
It's the square root of 3 over 2. Do you guys see it?
Yeah.
Find 120. Look at the y value. We good?
Yeah.
All right, let's do another one. Let's do cosine of 240 degrees. Cosine of 240 degrees. Okay. So Andrew, what is cosine?
Cosine is x value.
That's right. It's our x value. So now we're at 240 degrees, and I'm looking for the x value. So I'm going to ask Kiana to tell me what is the x value at 240 degrees. Sure is. Well, here's 240 degrees, right? And Andrew told us that it's the x value.
Oh, so 1 half.
It's negative 1/2. Okay? So the answer is negative 1/2. So let's back it up here. We're going to say negative 1/2. All right. So let me throw in at you guys now to do completely on your own here. So let's say I asked for what is sine of 225. I'll give you a moment to see if you can figure that out.
Okay. Question.
You guys good? Okay, now I'm going to throw something at you, see how you do with it. Cosine of 3 pi over 2.
Oh, wow.
It doesn't have to be degrees. It could be radians as well. So go ahead and see if you can find what cosine of 3 pi over 2.
Is that in a radical form an actual answer?
So let me show you why it's that. So first of all, one thing is we're dealing with radians, right?
Yeah.
So first of all, let's go to our circle. Now here's where that is, right? Now we want cosine, which is the what value? X. Now the x value there is 0, so there's no radicals on this one at all. It's just 0. Okay. There you guys go. All right, now that's the basic idea. Now let's throw another one at you guys. Let's draw a line here, your side and my side. All right, let's do secant of let me think. I want to pick one that does something special. Let's do secant of pi over 2. And let's also do cosecant of pi over 2. Now, this was going to be an example, but I think I'll show you. So let's do it. Ready? So secant. The first thing we got to do is ask ourselves, what is secant? So that's the first thing we have to do. So Cody, from today, what is secant? It's
1 over x.
there you go. 1 over x. Okay. So that means what we're going to do is we're going to look at pi over 2 on our unit circle. We're going to find out what the x value is, and we're going to put it there. So let's do that. Pi over 2 is right here, right? And the x value is 0, right? So going back, we have 1 over 0. What is that? That's undefined. So secant doesn't exist there. Okay? Let's do another one. How about you guys do cosecant of pi over 2? See what you guys get for cosecant of pi over 2. The answer, but like, what's the ratio?
1 over 1.
It's 1 over y.
Oh, my bad.
So that's going to be 1 on the bottom, and so the answer there is 1. Okay? Let me throw another one at you guys here. How about what is cotangent of pi? I'm going to throw cotangent at you there. So cotangent is x over y, right? Now, if I look at my unit circle, pi is here. And so x over y would be negative 1 over 0. Oops, wrong way. So that would be negative 1 over 0. And you can't have zeros on the bottom, so that's undefined. All right. Now, real quick here, I'll do this one. Tangent of pi. Now, tangent's the same thing as cotangent, right? Just flipped over. So it's going to be y over x, correct?
Yeah.
Now, that's 0 over negative 1. Now, what's that? 0. So make sure you remember that 0 on the top's okay. That's a 0 answer. But 0 on the bottom's not okay. That's undefined. All right? So now we're going to move into something that requires a little bit more calculation. Okay? Here we go. Let's do one of these. Let's say I have tangent of 60 degrees. Tangent of 60 degrees. Yeah, we're just going to do a bunch of problems until you guys have gotten all the different kinds of things that you need to know. Because it's all the same idea. We're just making fractions and simplifying them, right? But little things come up like undefined, zero, and this one I'm going to show you has a little bit of math involved that we have to deal with. Let's do Nathaniel. So Nathaniel, tangent is what? What over what? Y over x. Okay, so we're looking at the 60-degree angle. What is the y value there, Marissa? Good, so the y value is, oh wait, what's the y value though, Marissa? Yeah, the y value is radical 3 over 2 and the x value is a half, right? Okay. All right, so there's that. Now, that's a complex fraction. We've seen those before, okay? I'll show you guys how we can simplify those. What we did before when we were working on those is, I'll show you the work. What we did is we multiplied the top and the bottom by whatever the denominators were. Those 2s, you see those little denominators there? So I'm going to multiply the top of this big fraction by 2 and the bottom by 2, like this. You could do that so long as you do it to the top and bottom, right? And what that does is it cancels out those 2's, right? And what am I left with? Radical 3. And you don't need to put over 1, so we can just leave it like that. So that's our answer. So that's tangent of 60. That's a weird one, right?
Yeah.
All right. Let's do another one. Let's do tangent of 30 degrees. Now I'm going to let you guys go ahead and walk me through this one a little bit. Ready? So my first question is going to go to Alyssa. Alyssa, tangent is what over what? Good. Haley, what's the y value? Huh? 1/2 is correct. And then we're going to have Ale, what goes on the bottom? Good. All right, I'm going to let you guys simplify this for me. Go ahead and simplify it as much as you can. I'll pause. Get out here. Alex, what was your final answer there? He's got it right. So let's see how that happens. Ready? So Tia, what's the first thing we do here? Yeah. And what that basically is going to do is this 2 is going to cancel that one, and that one's going to cancel that one, and I'm left with that, right? So now, Anicia, what do I need to do? Yeah, we don't like square roots in the bottom. So that's going to be radical 3 over 3, and that's our final answer. Okay? That's about as ugly as it gets. It doesn't get any worse than that. Let's do it. Let me throw another one at you guys. Can you guys tell me what cotangent of 5 pi over 4 is, please? Go ahead and see if you guys can get that one whittled down to a nice simple answer. Yes, cotangent is x over y. So whenever I'm at the angle 5 pi over 4, Brianna, what's my x? Brianna? Oh, I'm sorry. I wasn't sure if you heard me. Good. And the y value? They are identical. Now I'm going to show you guys a long way to simplify this, just because it's good to see the math.
Okay.
But you can tell right away if you're sneaky about it, the answer is 1, right?
Yeah.
You guys see at the top and bottom are exactly the same.
Yeah.
And if you just divide something by itself as 1. But, you know, just in case you want to see the math. 2 over 1, 2 over 1, right?
Yeah.
The 2's cancel. Some of you guys did that first step and then you noticed they're the same.
Yeah.
And then you went for 1. But let's say you still didn't notice it. Okay. Now we multiply the top and bottom by the square root of 2 because we don't like square roots on the bottom, right? So that square root of 2 times square root of 2 is going to be 2, but there's a negative in the front. Square root of 2 times square root of 2 is 2, so there's a negative in front. And at that point, hopefully you notice that it's just 1. But yeah, the final answer is 1. All right, so that's that. How many of you guys feel like you need to practice another challenging one before we move on to anything else? You guys feel like you do that for any angle? You're shaking it. Do you think you could do any of these? Was that no? I'm not sure. I was asking, does anybody feel like they need more practice as well?
Oh, no.
Okay, okay. All right, so let's do this. So I want you guys to have your unit circles. And on your guys' can I borrow yours? Your unit circle, guys, has a section down here that we're going to fill out right now.
What she said, I know.
Sure. Okay. So we have one more thing that we need to memorize for our unit circles. I'm not going to be quizzing you on this one on Friday, though. I want to give you guys time to prepare your minds for just the coordinates. So I'm going to give this to you now, but I'm not going to quiz you on it for probably not even until the test day. But you do need to have your tangent values memorized. I'm going to be giving you guys the tangent values. Most unit circles that are out there, they don't even include these. But I've just found that by having them memorized, it makes life a lot easier for particularly solving equations involving tangent. So it's good to know them. All right. Now tangent here is going to be 0. Okay? Tangent up here is undefined. Tangent here is the square root of 3. We did that one earlier today. And then tangent here is square root of 3 over 3. We also did that one earlier today. We didn't do tangent to 45. But the x and the y are both square root of 2 over 2, right? And what do you get when you divide something by itself? 1. Okay? Now, last time we had a lesson, we talked about how the coordinates are symmetrical. You can just take the coordinates from this side and flip them over to the other side, right? Well, since this is just a fraction of those coordinates, then guess what? This is symmetrical too. So, for instance, if this is radical 3, so is this. If this is 1, so is this. If this is radical 3 over 3, so is this. And if this is 0, so is that. Now, I'm going to talk about signs in a minute because there are some negatives, and I'll show you how you can know in a minute. But for now, let's just get the numbers on there. Okay, if we take the top half and flip it down to the bottom, the radical 3 over 3 matches this point. So this is radical 3 over 3. This is 1, and this is radical 3. This is undefined. This is radical 3, 1, and radical 3 over 3. So that's another set that you're going to want to commit to memory. But I wouldn't start sweating it until Friday. I'll try to remember to put that on the board for your Friday homework to memorize your tangent values. You're still working on coordinates, radians, and degrees at this time. But this is the time I scheduled to have it done. So we're doing it today. Now let's talk about the signs of these. Positive versus negative. Now you guys know that tangent is x over y, right? No. It's y over x. Sorry about that. Y over x. Now, there's two ways that this could come out positive. One way is if they're both positive. The other way is if they're both negative. So, tangent will be positive when either both x and y are positive or when they're both negative. So, in what quadrant is both x and y positive? 1. So all of these are going to be positives. In which quadrant are x and y both negative? In 3. So it's positive here as well. However, in the other quadrants over here, since only one variable is negative, then when you divide a positive by a negative, you get a negative. So these are all negative. Same thing over here. Okay? So it behaves a little bit differently than the other one, but there you go. They're diagonal from each other.
Well, this one's kind of easy to remember, honestly.
That's what, yeah, they said in the last one too. But we won't worry about memorizing it until Friday. All right, so there's that. The last thing I want to throw at you guys for today. Now, you guys could figure these out using everything that's taught you, by the way, but memorizing them is a lot easier. The last thing I want to throw at you today is weird angles. All right. What did I do with it? Oh. Weird angles. Talk about weird angles. Okay, so what we're going to do, guys, when you have a weird angle, by weird angle I mean it's an angle that's not on our unit circle, right? Is we're going to add 360 to it or subtract 360 from it, or 2 pi if we're talking radians. We're going to add and subtract the full circle until we get a normal angle that's actually on the circle. So we're going to convert it to a normal angle. So negative 60. If I want it to be normal, what am I going to do? Add 360 or subtract 360? You're going to add 360 to it. And what does that become? So we've converted it from a weird angle into one that's actually on our unit circle. It's the same spot, it's just a different measurement. So since it's at the same spot on our unit circle, it should have the same x and y values and stuff, right? So sine of negative 60 is the same as sine of what? 300, which is on our unit circle. Sine is the y value. So what is the y value at 300 degrees?
Negative radical 3.
There you go. All right,
That makes sense.
good. No, it makes sense. All right, student practice. Let me throw in at you guys. How about cosine of I'm trying to do some math in my head. Just a second. 480. Let's see if you guys can find cosine of 480. The angle I'm looking at here, is it too big or too small? It's too big. So what am I going to do to convert it? That's right. We're going to subtract 360 from that angle. So it's going to be 480 minus 360. And what do we get by doing that? 120. So cosine of 480 is the same thing as cosine of 120. And now we just get to figure that out from there. So it's cosine is the x value, and the x value at 120 is negative 1/2. Okay? Let's do another one. Let's do sine of 9 pi over 4. Example 2a. All right, so we look at our unit circle. We see it's not there. That makes it a weird angle. So what we're going to do is we're going to either add or subtract 2 pi from it. Now, is this bigger or smaller than 2 pi?
Bigger.
It's bigger because 9 divided by 4 is like 2 point something. So what I'm going to do is we're going to take 9 pi over 4 and we're going to subtract 2. I wrote that really weird. We're going to subtract 2 pi from it. Okay, so you guys get to do some math here. I'm going to let you do the subtraction, okay? Just to practice your fraction work. So go ahead and subtract those and see what you get. You're a bad person, Kevin. So in order to subtract, then what do I need to do?
Get the same number.
Yes. So I'm going to put this over 1, and then I'm going to multiply the top and the bottom by 4, right? And what does that become? 1 pi over 4. Now that is on our unit circle, correct? All right, so we're looking, so sine of 9 pi over 4 is the same as sine of what then? Pi over 4. It's the same angle. Well, it's at the same spot because they're coterminal angles. And sine is y, so what's the y value there? There you go. So just got to convert them.
Oh, I did 4 times 2, I put 6, but I still got radical 2 over 2.
Okay. Let's do one more. This is for you to do, and then we'll be done for today, okay? So let's do cosine of negative 2 pi over 3. Cosine of negative 2 pi over 3. Now, negative 2 pi over 3 is not on our unit circle. That's a weird one. 2 pi over 3 is, but not negative 2 pi over 3. So we need to convert it. Okay? So, Jackie, we've already identified that that's not our unit circle. It's too small. So what do we need to do to it? We need to add 2 pi, which means we need a common denominator. Adeline, what did we get by combining these? Yeah. 4 pi over 3. Let's see why it's 4 pi over 3. We're going to multiply the top and the bottom by 3. 6 take away 2 is 4. So we have 4 pi over 3. So cosine of negative 2 pi over 3 is the same thing as cosine of 4 pi over 3. Cosine is x, and the x value there is negative 1/2. Okay? All right, that does it.